Woohoo! We are live. This is Math 60, Intermediate Algebra 5.6. And before we get into 5.6, we're going to do some preliminaries for 5.6. So this is almost factoring trinomials. But what I want to do is I want to review a little bit of multiplication. So we're going to use FOIL to multiply two binomials. First, outer, inner, last. So you'll recall that first are the first two, that's x times x. Outer or outside are the ones on the outside of each of their binomials. So that's x times 2. I stands for inner, that's these two, 1 times x. And the last are the two that are last in each of their respective binomials, 1 times 2. It's all addition, so we got pluses running around everywhere. And so I get x squared plus 2x plus x plus 2. Now, this would be it, except the middle two terms can be combined. So I can get x squared plus 3x plus 2. This is a trinomial. And it is a special trinomial. It's of the form ax squared plus bx plus c. And that's what we're going to be working with. Sorry, you can't see the word trinomial. That's what we're going to be working with in 5.6. We're going to be factoring these. Now, if you take a look at what happens, the multiplication that got us to the trinomial involved two binomials. So that's what we're going to focus on. When we get a trinomial of the form x squared and then an x and then a number with a bunch of coefficients, we're going to look for a pair of binomials which multiplied together give us this trinomial. And just to put in the circle of life, x plus 1 times x plus 2. If we come around the circle, when we multiply, we end up with x squared plus 3x plus 2. And then we can go back to this form if we ask you to factor. So these are two different forms. This is the factored form. This is the trinomial form. And they are equivalent. These two, x plus 1, the quantity, times x plus 2 equals x squared plus 3x plus 2. It's just that this is a factored form and this is the multiplied out form. So this is the factored form. And this is the multiplied out form. And so for the rest of this chapter and the rest of this class, you're going to need to pay careful attention and find out, do we want the polynomial multiplied out or do we want it in its factored form? So we will have different answers to questions depending on which one we're looking for. In 5.6, we're going to learn and practice how to factor trinomials. And I'm going to use, to begin with, a method called trial and error. Now, here is a bunch of pedagogy and theory before we get started. There are two main ways to factor trinomials. The old way from, like the 1760s or even the 1970s when I learned it is called trial and error. The new method is one that we're going to be talking later on, and I'll show it. It's got a whole set of formulas. You multiply things, and then you have to say some magic words, and everyone has to stand in a circle holding hands, and then you get an answer magically. So we got the two methods. One is trial and error. One is magic. And you're welcome to use either way. I'm going to start with the trial and error method because honestly, I believe from watching students practice, when you use the trial and error method, you actually get fast and you get really good, and it helps you, it builds your skills. So those of you going on to calculus, it will really help you develop your insight around polynomials. The magical method, which is actually on the face of it, it looks very complicated, but you'll see with a little practice, it's pretty easy. The problem with this method is there's so much about it that you have to write things down that you don't get as fast as the trial and error people. So let me start with trial and error and see what y'all think. So here we go. I have got x squared plus 5x plus 6. And what I want to do is I want to find two binomials which when multiplied give me this polynomial. And I'm using the fact that I know if it's two binomials, this will be the f, this will be the oi, and this will be the le. So this will be the first. These are the two middle terms that add together, and then this is the last. So what I can do with this is I can say, okay, starting off, I've got x squared. So that tells me I must have an x in each position, right? X times x is x squared. Now, the 5x is a little hard because basically what I'm looking for is I'm looking for two numbers that add to 5. And you can imagine there are a lot of these. 5 plus 0, 1 plus 4, 2 plus 3, 3 plus 2, etc. So I'm going to skip the oi. I don't look at the oi. First, I look at the first one. And then last, I look at the last one. I say 6. And I say to myself, what times what gives me 6? So I could have 1 times 6. I could have 2 times 3. I think that's pretty much it. Then what I do with each of these possibilities is I try them out. This method is pretty basic. There's nothing fancy involved. Trial, and then you'll notice half of it is error. So half of the time you're going to try something and it's not going to work, and you're going to, come up with some new swear words for yourself, whatever gets you through, and then you try another one. So for the 1, 6, it would look like this: x plus 1, x plus 6. So let me try that. What I'm going to do is I'm actually going to FOIL this out. X times x is x squared, and then outer is 6x, inner is 1x, and last is 6. And we look at this, and we look at this, and we say, are these the same? This one ends up being x squared plus 7x plus 6, and this is the wrong one. So I know it's not 1 times 6. So let me try 2 times 3. That would be x plus 1 times the quantity x plus 3. Okay, I FOIL it out. X squared plus 3x plus 2x plus 6. That's x squared plus 5x plus 6. That's what I'm looking for. This is the answer. And that's it. There's nothing fancy about this. You just try stuff, and if you find something that works, you stop. Okay, woohoo. That's how we're going to do the rest of this page. Next up, 9 squared. Let me write it again down here. I know I am now famous, for maybe infamous, for not giving myself enough room. I'm going to do the same thing. Y squared minus 9y plus 20. I got a y and a y. Now here's the thing. Where's my handy dandy marker? Let me see if I can make this not smear. It smeared a little bit. There's a minus. If there's a minus anywhere in the problem, then some of your numbers have to be negative. So I have to come up with two numbers that multiply. So it's something times something, and they have to equal 20, but at least one of them has to be negative. So what are the possibilities? Well, I think about it, and I was like, if at least one of them has to be negative, but I end up with a positive number, they both have to be negative. This is going to be two negatives. So negative 1 times negative 20, negative 2 times negative 10. Let's see what else makes 20. Negative 4 times negative 5. Now, I only, in this case, for this first page, you'll notice x squared, y squared, x cubed, x squared. What they all have in common is that the coefficient for the leading term is 1. There's just 1 out in front. If that's the case, you don't have to go through all of them. You can just go up to halfway. See how this is 4 and 5, and then the next one would be 5 and 4. We can stop there. So this would be y minus 1 times y minus 20. Very quickly, y squared minus 20y minus y plus 20. This would be y minus 2, y minus 10. So that's y squared minus 10y minus 2y plus 20. The last one would be y minus 4 times y minus 5. Now, if you're watching along at home, and especially if you've gotten really good with your foiling, you probably already saw what was going to happen to begin with. You could see that 1 and 20 and 2 and 10 were nowhere near what was right. But with that minus 9, that the 4 and the 5 were going to get us there. And in fact, it does. This one is y squared minus 9y plus 20. That's the right one. So this is what I put a square around, because that's y squared minus 9y plus 20 factors as the quantity y minus 4 times the quantity y minus 5. Woohoo. Let's try another one. Okay. I threw in a curveball just because that's what math is like. This one is different because right off the bat, there's a common factor of x. So if you do see any common factors, factor them out to begin with. It's going to make everything a lot easier. Having said that, then I've got this x that comes along with it, and then a couple of x factors, because again, this is a trinomial, x squared, x constant. And so I'm going to factor it as x and x. Now, here's the interesting thing. The number I'm looking for is negative 30. How can I make negative 30? Well, I could do negative 1 and positive 30, or I could do 1 and negative 30. I could do negative 2 and 15, or I could do positive 2 and negative 15. Right? To make a negative, one of them has to be negative. So these two are different because they take turns being negative. I could have negative 3 times 10, or 3 and negative 10. I could have 5, negative 5 times 6, or positive 5 and negative 6. Now, what you might have guessed from the previous two problems is there is a trick to this. As long as the coefficient of the first term, that leading term, is 1, you can guess what the correct answer is by adding these. Negative 1 plus 30 would give us 29, or 3 plus negative 10, that would give us negative 7. And that will give you the value that goes in the middle. So if you look through these, you look for two numbers which add together to give me this middle number, negative 1. La, 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 la. And here I'm going to intentionally, don't panic. I'm going to get it wrong. I'm going to say, because this is trial and error, so I'm going to try x minus 5, x plus 6, and show you what happens. I get x squared plus 6x minus 5x minus 30. So that's x squared plus x minus 30. So let's compare this with what we were looking for right there. It's very, very close. The numbers are all right. The one thing that's wrong is this right here. This, sorry about the smearing, that plus right there. We wanted a minus. So if the numbers are all right, but the sign is wrong, look at your problem and try swapping the sign. So I'm going to do plus 5x minus 6, x squared minus 6x plus 5x minus 30, x squared minus x minus 30. There we go. There it is. That's the happy one. That's how to factor that guy. Shall we try one more? Woohoo! Super fun. Okay. X squared minus x minus 7. So I want to break this down as x something. So that's the first. I break that down, and then I look at negative 7 and I say, okay, how do we make negative 7? Negative 7 could be negative 1 times 7, right? or 1 times -7. Now 7 is prime, so there's no way to break it down in any other way. So let's try one of those. So x minus 1, x plus 7. I get x squared plus 7x minus x minus 7. That's x squared plus 6x minus 7. I check it. Nope, that's not it. Okay, keep going. Let's try the other one. X plus 1, x minus 7. I get x squared minus 7x plus x minus 7. That's x squared minus 6x minus 7. This one is also not correct because it's just the opposite of this guy. I just get, in this case, oops, you can't quite see it. Let me bring it up. Sorry about that. So here, when I did x plus 1, x minus 7, x squared minus 7x plus x minus 7. That gives me x squared minus 6x minus 7. It's really just the opposite in the middle from the previous one, but it is not giving me that minus x that I'm looking for. Both of these have 6's, plus or minus 6. So this one doesn't work either. So I double check. Is there any other way to break down 7? There is not. So this one is prime. Now, full disclosure, this one is prime. It is absolutely prime, but it is only prime under certain conditions. And there are going to be a lot of polynomials we're going to call prime in Math 60, which later on in math, you're going to find out there is a way to crack. There is a way to factor this. It is not pretty. It's not nice. So we're going to have to learn a bunch of other stuff, but we will come back to this. And if you continue on to Math 90, one of the theorems that we go through is that all polynomials can be factored. However, you have to use some really creative ways of factoring them, and you have to use sometimes a brand new number system. Okay, I know that's mysterious. Ooh, that's exciting. Very Indiana Jones, Nicolas Cage, and the imaginary numbers sort of thing. So next up, we will continue on with factoring in 5.6. Woo!